It's 8 o'clock on the dot. I'm in my drop top, cruising the streets. Brown, 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 brown. If you didn't know that was the wrong time, then you are either too young or too old. Nah, I'm not at home. I just turned the, I'm not at home. I just turned the camera because I'm in the midst of a monitor. I'm in the midst of a monitor switch. So I had to move the camera over here for today. It'll probably be different tomorrow. I'm combining my monitors. I picked up a few monitors over the years. Kind of combining some things. I bought an ultra wide, and it's been working well for this. It's like a 38-inch like curved Dell ultra wide, but I also had some other things, and I bought in a monitor on Friday because we played some games on Friday. So shout out to anybody who was on that kind of just chill session. But yeah, I'm like in between setups right now, so I had to move it over to the left. So you're getting a little more view of the office space, which will actually it'll probably look different also in a few days, probably on March 1st or 2nd. We're moving into a different office actually. So it'll look even different. So I'm just trying to get everything set up before then. But how's everyone doing tonight? I'm excited. We're in what are we in, week 8? Hold on, let's find out. I'm also used to looking right here and not right here. So you might see me looking the wrong way a couple times, but I do have a monitor that's like the monitor I'm actually gonna be using is right here. Let me lower this. It's actually over here. So it should keep me from looking extra stupid. All right, hold on. Let's open up a new window. What week are we in? Academy.mastermind.io. We started, I think we're in week 8. So 1, 2, 3. No, we started here. 1, 2, 3, 4, 5, 6, 7. Started week 8. So we are really pushing through. This looks too large. Let's check out the curriculum. Let's talk about what we're going to be doing tonight. So the major concepts we've covered in these 8 weeks so far, 7 weeks so far. Learned a little bit about DevOps, also a little bit about programming, specifically Golang. Just for anyone who was interested in that first part that we were doing with Golang, we will be doing a lot more with Golang. So keep your eye out on that. And we're doing a whole lot more with Golang in the future. It's probably going to be the language of choice to teach computer science topics, things like that. So we're probably going to be using that as opposed to like Java for some of the more complete training things. So keep an eye out for that if you're interested in Go. A lot of stuff about Go coming up. So we learned a little bit about operating systems. So we learned about, Linux. So that was good. Web servers, traffic management. We dove into the cloud. We just got done diving into the cloud. Learn some different pieces there, and we're going to keep using the cloud as we dive into the rest of this. But we're finally to the infrastructure as code piece, and this is going to be exciting. This is going to be important because a lot of DevOps positions. We talk about a lot of things that DevOps is, kind of what it isn't, but a lot of DevOps positions are systems administrators who can manage infrastructure using these infrastructure as code practices and tools. So if you're someone who's already a systems administrator or dealing with systems, this might be the most important piece to you right now to immediately kind of move into what is a DevOps role. These are kind of the tools that kind of allow us to achieve these DevOps workflows. So tonight should be pretty fun. Tonight we're going over configuration management as a whole, as well as Terraform. When we get to the next part, you see how we are not going to go over any more configuration management overview. Next time we get to Ansible, we'll spend the entire time doing things in Ansible. We'll spend most of the time tonight using Terraform, but we do need to go over configuration management, which will cover kind of both of these, infrastructure as code and configuration management. Yeah, there's some interesting paradigms here that should be fun. But yeah, still be at Spark. I'm literally moving like 3 offices down. I needed a tiny bit more space because I got a bunch of crap in here. So just moving down the hall a little bit. So I still will be at Spark. All right. So hopefully everyone who's in the classroom got the slides, but if not, let me close the door. I'm getting a weird echo. Cool. Let me get you guys some slides. Drive. All right, share. Might be too loud there. Get shareable link. Because everything's off to the left, I don't have as easy access to the chat, so I'm gonna have to be extra cognizant of the chat tonight, just because I don't have easy access to it like I'm used to. I gotta like turn my head this much, which isn't that much, but usually I can kind of see out of my peripherals when new messages are popping up, and I can't quite do that tonight. Anyone want the link? Here we go. Let's share it out. And let's get ready to go. Actually, give people a few more minutes. I've kind of let people get accustomed to the 8:10 real start time. So wait around for just a few minutes. I'm trying to think if I have any announcements, but I don't think I have any announcements for this. If you're interested in the Python bootcamp, we're going to be getting into object-oriented programming this week. So that's what we're going to spend most of all of our time doing this week in that one, so be ready for that. Also, actually, I'm going to save that. I am going to save that information until I have some specifics on it. I have some updates. I definitely have some good updates. What's up, Sandrio? Welcome to the channel. Thank you for the follow. All right. Let me make sure everything's set up. How's the music? Is it too loud? We moved everything around for Friday. So anyone who didn't know, Friday was just, I said in the beginning that I would do a couple of like office hours, like Overwatch and office hours, where we play some games, just kind of talk about different things, whatever came up. But we ended up just kind of playing games the whole time on Friday, just kind of having fun. We're like winding down from the week. I needed it too. The end of last week was a rough work week, to be honest. A lot going on. This week's gonna probably be rough too. I have a lot of things that are due for a bunch of stuff. And like I said, I don't know what I'm allowed to announce yet, so I need to find out if I'm allowed to announce some of the stuff yet, but I'll find out for sure. Cool. Looks like everyone's in. We'll go ahead and we'll get started, because I don't really have anything else and I don't want to ramble. How do you find out about office hours? So because that's been so, that was the first one. Because it's been so sporadic, I wasn't sure when I was going to be able to do it. I'll probably be doing it more often now. Generally, I'll let you know all week on the stream. I'll try to let you know all week. I try to announce it every stream last week, but probably Twitter and LinkedIn as well. But I'm gonna start putting more on that calendar. You can go to the Academy website and you should be able to, I think those links still work. You should be able to click the Google Calendar here to be able to follow the calendar for the bootcamp. I'll try to add it. I remember to add it there as well, but I'll try to tell you. I'll know at the beginning of the week whether or not I'm going to do it on Friday or not. So I will let you know. All right. So now the cool stuff. Infrastructure as code. We are now, I think we're in the cool stuff. This is the cool stuff. So repeatable, reliable, consistent. This is the goal of infrastructure as code. So what is infrastructure as code? What is IAC? You'll see it written as IAC pretty often. So just so you're familiar with that, I think I use this nomenclature throughout the rest of the slides, I believe. But yeah, so infrastructure as code. And you've seen the top thing before in the Golang section, but function build me a server, basically. So infrastructure as code, or IAC, is the process of managing and provisioning computer data centers through machine readable definition files, rather than physical hardware configuration or interactive configuration tools. Again, bunch of words. Let's break it down a bit. It is the first. What is it? We want to know what it's good for. What's up, Gustavo Mister? Welcome to the channel. Thank you for the follow. But what is it good for? What problem does infrastructure as code solve? That's the most important piece. But it allows us to manage and provision computer data centers through machine readable definition files. So it says computer data centers. This is an interesting word usage, because while this is true, you can use these tools to manage things inside of a data center. You can also use them to manage things via cloud, but it's just computer resources. And so you're provisioning and you're managing computer resources through machine readable definition files. So files, you basically are going to be writing or defining files with your desired state of infrastructure. And these machines are going to be able to read it, take that information in, and configure themselves or other machines accordingly. And so this is, as opposed to you manually logging in like we did with the Linux portion and with the cloud portion. We manually went through and we clicked through the AWS interface and we spun up Ec2 instances and we said, hey, we want a T2 micro server and we want Ubuntu as the operating system, and we want this key used. We did all that manually. Infrastructure as code will allow us to define these things through machine readable definition files, so that we don't have to do things manually, which is great. So why would you want to use infrastructure as code? Very important. One, it creates consistent and reusable ways to deploy and manage infrastructure assets and configuration. A lot of words there too. The keywords here are consistent and reusable. So you can write, it may take you a little bit of time, but you can write this code, you can define this configuration one time, and you can use it to deploy things consistently and over and over again. You can reuse them as needed, which is really nice. So instead of me having to do what we did last time and spin up 3 different web servers to load balance in between and manually log in and manually update and manually install Nginx and manually configure them and manually download all of those site files that we downloaded to the servers and put them in the right directories, we no longer need to do that. And we made that process a little bit easier by writing a script. You'll learn more about how scripts fit into this a little bit later. But this way, infrastructure as code allows you to consistently do that and create these reusable definition files for you to deploy these things. And also notice that it says to both deploy and manage infrastructure assets and configuration. So not only can you actually provision web assets, not only can you create S3 buckets and create EC2 instances, you can also configure things. So you can take running servers and you can set them up accordingly. You can make changes to them. You can say, hey, I need these users on these machines, and you can define it in one place, and it can apply to a bunch of things. So number 2, help prevent configuration drift. So what is configuration drift? Configuration drift is when you have a desired state of configuration, and over time, through whatever reasons, that state becomes off. So generally, this is attributed to kind of the old way of doing things, where you'd have maybe a server farm, you maybe have 10 servers here, and you're manually updating them, you're manually deploying to them. And maybe we log in to make a change to a bunch of them, and we fat finger a file in one of the servers, and the configuration becomes a bit off in one of the servers. And then later down the line, we're trying to do an upgrade or something, and maybe another server fails to install a package because the network went down or something like that. There was a network blip, and now that server is missing a package. And then before you know it, this desired state that we started with is no longer true for all the servers. And so they've drifted out of their proper configuration. This is a very common thing, but infrastructure as code allows you to prevent that. Or if it was to happen, it allows you to like kind of reset things and make sure the things that are in the desired state that you set for them up front. The third thing, free documentation. This one is great. Documentation is a huge problem with all of tech. Generally, people are bad at documenting properly what their code does, why some decisions were made, how to use things. But what this does is, what infrastructure as code allows you to have is, when you start a new job, and before infrastructure as code, you walk in and you say, all right, what's going on here? I don't know how this infrastructure is set up. I don't know how this company is, how their things are set up. And so what I have to look at, I probably have to look at some network diagrams and some architecture diagrams and things like that, and kind of mentally piece together the things that are going on. Infrastructure as code allows you to be able to hop right into GitHub. And again, this doesn't work until you know these things, till you have a good understanding of infrastructure as code and the different tools. But you can look through these files, you can look through these definitions, and you can see what the infrastructure is supposed to look like. You can see what it pertains. You can see, again, where there's S3 buckets. So you can see how many databases you have, and you can see, I can look at the network and I can see how many VPCs we have and how many subnets are in each of the VPCs. But it gives you some free documentation for your infrastructure, so that when people are joining, if you need to share with anyone, you have that already set up, which is great. Speed. 4 is speed. This is a big one. It is to do things manually. We all know that to do things manually, computers are faster than human beings. To do things over and over again manually takes a lot of time. Infrastructure as code allows you to deploy things faster. It allows you to configure things faster. Usually there are some very small instances where that's not the case, but generally it's going to be much faster to be able to do these things. Especially if you need to make changes to massive amounts of servers at once, or be able to provision lots of systems all at once. Infrastructure as code allows you to do that very easily. And then there's automated infrastructure. So we're not on to, we did a little bit with automation, but we haven't gotten to the CI/CD process yet. But because this is handled through code, we can manage our infrastructure the same way, and we can automate it in the same way that we automate the building and the management of the application code. So infrastructure as code configuration files can live right along with the actual application code, which is really, really nice. Again, that might not make any sense now or be applicable. Let me go back. But it allows you, because it's code, it allows you to be able to use other tools outside of the actual tool. So I can use bash scripts. I can use all kinds of things to automate processes and things within my actual infrastructure, which again before was impossible, really it was impossible because you were dealing with physical hardware that you needed to mess with. But yeah, it allows you to automate your infrastructure. So this slide is a great slide to kind of just read over and kind of pick up. I think they're good talking points if you're in a interview or something. It might be a good way that once you kind of learn the tools that kind of fit in here, you're gonna learn some of the tools tonight. You may be able to more easily talk about what problems these things solve. Without having to, truly know how to use that application. But just a good slide, so you may want to put a little star next to it to kind of check out there. Feeling from work is that code drift is one of the main reasons for annoying bug hunting. Absolutely. Our large upgrades that we had to fix manually because the prod wasn't the dev. Yes. Yeah. So this doesn't solve all your problems. It really does help. You need to have a workflow kind of around your infrastructure as code to make sure things like that don't happen. Things like that can still happen. Your defined configuration can be different for dev and prod. So you just got to make sure your workflows are right. But this makes it substantially easier to be able to mitigate issues like that. All right. So let me get a little bit of water real quick. Again, I stayed away from the LaCroix for one more night. Actually just forgot to go grab some. So I got regular water here. And you see I got my Hack Baltimore sticker. I'm going to put a Hack Baltimore panel up one day because I'm really excited about what that is. And I'll give more information about it as well, but cool. So now is it now not gonna come out of focus? Oh well, you guys don't care about me. We care about the code. So pillars of infrastructure as code. So these are not, this right here is not an industry-wide thing. You don't have to memorize the pillars of infrastructure as code. These are the pillars that I see as infrastructure as code. These are the three kind of pieces that I see make up what people talk about that prop up this infrastructure as code thing, because I think this part is important, because I think there's a lot of debate where certain things fit, and I'll tell you why these are under the pillar as we kind of go through them. The first one is infrastructure provisioning, and so that's what we're going to be talking about tonight specifically. These are tools like Terraform. The next slide, I believe, is actually cool. We'll go through them. I was about to talk through them, but we're going to go through them. So infra provisioning, so that's infrastructure provisioning. Then there's server and software configuration management. And so that's going to be things like Ansible, and then there's scripting. So these are the three things that I think are all absolutely infrastructure as code, and can allow you to automate your infrastructure, define the state, define the desired state of your infrastructure, get you that documentation and everything. So let's talk through those really quick. How good are we on time? Perfect. We're good on time. Provisioners. This is the first one. Provisioners allow you to define and build infrastructure assets from source files. So those assets, again, are the actual tangible web resources. So again, these are things like Ec2 instances and IP addresses and subnets and storage devices. So EFSs and RDSs, databases, things like that. So this is the actual definition and building of actual infrastructure assets rather than configuring them. Just building these things in the desired state that you want. And these are what provisioners do. And is the next slide. Okay. These are the provisioners. So take a moment there. And it may make, like, once we go through the next two options, it may kind of make a more clear-cut thing of what this is. I know that I had trouble when people used to say words like infrastructure assets to me before. I was like, I don't, like, what does that mean? Like, you're saying things. Again, hopefully through our demo tonight that you'll be able to see exactly what infrastructure assets are. And then when we get into Ansible next week, you'll be able to see kind of the differences in the things that provisioners versus configuration management tools versus scripts, kind of what they what problems they solve and what they're kind of good for. Let's see. Terraform is cool because you can deploy to OVH, Google Cloud. Yes. Outside everything is centralized to one account, personalized like those. Each file with at least 5 different computers. We're gonna talk about that in a second. Google doesn't. Okay, well, Terraform is very interesting. I've learned a lot about Terraform over the last year. I'm hoping to learn more, but we're gonna talk very deeply, specifically about Terraform in a bit. So some of the vendors, just some of the popular tools. And when I say vendors, these are all companies that provide configuration management. I'm not configuration management. Provisioning tools, and these are kind of the major vendors here. There are more than this, but Terraform, that's going to be the one that we use tonight. This is probably the largest. CloudFormation might still be bigger, but Terraform is like the hottest one. It's good for a number of reasons. One, it is kind of vendor agnostic, they have this paradigm called providers, which allows you to basically be able to build out options for any type of provider, cloud provider, any kind of platform you can use. So you can use this with AWS and Google Cloud and Azure, and you can use it with VMware. And I'm going to show you a page with a bunch of different providers, which is super nice. But yeah, Terraform is what I would always recommend going to right now, to be honest. I think it's a pretty easy win if you have the choice. Another one is Pulumi. Pulumi is definitely getting bigger. It does, it solves the same problem, not nearly as mature. I think Pulumi is a little bit better for developers. At least last time I saw it, it's better for actual software devs. Because I think you're generally doing, I think you used to be doing it, you're basically writing Node to be able to configure this infrastructure and to provision this infrastructure. I think they have some other options now, but I've heard some good things about it recently. Haven't checked it out in a long time, but something I think you should be aware of. The bottom left one, AWS Cloudformation. This is a touchy one for me. So this is, Pulumi works with other vendors besides AWS, but not as many as Terraform. AWS Cloudformation It only works for Amazon. So this is a tool, one of those services, one of those 176 services or whatever, provided by AWS. So if you're heavily ingrained in Amazon Web Services and that's all you're going to be using, feel free to use this. It works. I think it's very difficult to learn. I think it's very difficult to understand. I think it takes a long time to get your head around it. But again, it's something that AWS provides. It's right there, and you can use it. It works. I use it every day. I do not like it. I would prefer to be using Terraform. So we do for some things, but we started out this project using Cloudformation, and yeah, it's got its quirks, but it works. It works, but not fun. Don't use this. I would not use this if you didn't have to. I wouldn't just choose to use this. And then the last one is Vagrant. People are always surprised when I talk about Vagrant in this provisioners category. So Vagrant is kind of specific to virtual machines, but it allows you to do the same thing to kind of define these states for these virtual machines and be able to much more easily spin these things up. Vagrant is a little bit of a hybrid. And so I could put it on both here and the next one, but I just think it's a good tool for you to know about. Vagrant is also made by HashiCorp, or at least managed by them. I don't know if they originally made it. But yeah, HashiCorp, they do a bunch of tools. But yeah, just some good provisioning vendors for you to know about. Let's see. All right, so infrastructure as code with provisioners. Now we're on the configuration management. So let's see how configuration management differs from your provisioners. So in DevOps specifically, because configuration management has, that term has a meaning in a bunch of places, actually. But in DevOps specifically, configuration management is an automated method for maintaining computer systems and software in a known and consistent state. All right. Automated method for maintaining. So maintenance, maintaining computer systems, basically keeping them in a running state, and keeping them in a known and consistent state. So the difference here is they both are used to define a state and exactly what you want. But configuration management is used to configure and manage the resources that are spun up from provisioners. So provisioners will create the resources, and they also have the ability, there's definitely some overlap. Provisioners also do have the ability to do some setup and some of this configuration management, but that's not what they're designed to do. Those provision those Ec2 instances and things, and then the configuration management tools kind of come in behind them, and then they actually configure those Ec2 instances with the things that you want on them. So again, if there's supposed to be a certain set of users, it'll set up all the users and groups, and if there needs to be certain packages installed, applications, certain repos that need to be cloned down to the system, it will do those things. Not only does it do that, in the initial setup, but it also keeps these servers up to date. And so this is what stops that configuration drift, keeps these things up to date while they're running. So there are a lot of people implement kind of a check-in. So there's different services, Chef, Puppet, we're gonna go over those in a second. But generally, usually your servers will be set up using them, and then they'll basically check in every 30 minutes or something, and they'll check in and it'll say check in with Ansible or check in with Chef, and it'll say, hey, I know I'm supposed to be in this state. Am I still in this state? And if not, if things are missing, if I logged into a server and it was good 28 minutes ago, but on the 29th minute, I went in and I logged in and I deleted my user, but my user is defined in these configuration files. It will put, if it says, hey, I don't see this user on the system anymore, I'm going to go ahead and put this user back. So it will keep your systems maintained in a consistent state, which is nice. Let's talk about some of the vendors first. Chef is a huge one. Puppet, also a huge one. I think Puppet might be the oldest. With Ansible here, that's what we're going to be learning, and we're gonna have Salt Stack. I'm pretty sure SaltStack is the smallest or the least used of them by far, but all still use. They all do. I've used them all. They all do the same thing, but they approach it just a bit differently. Why would you want to use one over the other? So Chef is Ruby, is built in Ruby. It allows you to do a little bit of hacking with Ruby as well, which is nice. Some people, this was generally as opposed to Puppet or Ansible, this was kind of the developer's configuration management tool. All of these use something called a DSL, which is a domain-specific language. So they all have configuration files that are kind of their own language. So when you move to each of them, you kind of have to learn their language, which isn't really hard. You just kind of got to learn the structure of kind of how these things work, of how each of them kind of want things to be set up. Puppet, I think Puppet is also Ruby. I don't remember if I haven't used Puppet. Was the first one that I ever used, but I haven't used it in a while. Ansible, people like Ansible because Ansible is agentless. It's kind of nice. I don't yet know if I like it because of that reason or not. We'll talk about agentless versus non-agentless and all that other stuff. And kind of how these work differently. This works through SSH, whereas like Chef and I think both Puppet work through HTTPS, and why that difference matters. We'll definitely talk about that. Okay, cool. Puppet is Ruby. We just say Ansible is agentless. SaltStack, I think SaltStack is Python, I believe. I think Ansible is Python as well. If anyone knows, let me know if I'm wrong about SaltStack. But Ansible, I'm pretty sure is Python. But yeah, these are used to define the configuration of the server. Again, the same way that we logged into those servers and we set up things like we installed Nginx and put configuration files into place. These are used to define those states. If we're supposed to have a configuration file somewhere that's supposed to have specific things, we can make sure that we can define it in these tools, and it'll go through and it'll make sure those things are on the server for us. I actually if I can, as much as I love these tools, like these tools changed my life as a sysadmin, learning that you could now manage. I could basically write some code, write these little manifests and say, hey, I want these users, I want these applications of these versions, and I want them to be running at all times. And if I need to make an update, like go ahead and restart and all this stuff, I could define that. And then I could deploy it out to all the servers that I had, or when the servers checked in, they would get the right configuration updates. It kind of blew my mind because I was used to logging in the servers manually and changing things because that's just how you kind of did things, or you scripted it out in some weird way. But yeah, these things are really nice, and it'll make a lot of sense once we get into Ansible. And I think moving from a provisioner, we're using a provisioner tonight, into a configuration management tool next time, I think is great. And I think it'll put a lot of context around the problems that they solve. So the last thing is scripts. I don't know why I didn't put it on here. Scripts is the last piece. We've talked about scripts before, but scripts are a form of infrastructure as code. The problem with scripts, or not problem, but the thing that scripts lack that the provisioners and the configuration management tools provide is consistency. Scripts generally don't have a way to, they basically will run and kind of get things how you want it, perform some actions, but they generally don't have a method of making sure things stay that way. So, but scripts can absolutely be utilized to do that. I always tell people, if they're always like, how do I start my DevOps journey? Like a company, especially like if you're trying to figure out where do I start with DevOps, I always say automate some things, use some script, write some scripts to automate a few things. And that's kind of how you start your journey. Scripts are things that you can keep, version controlled. You can manage those with your code, with your code base. So scripts absolutely should not be forgotten as a part of the pillars. But we've done some scripts. We've done some bash scripting in the Python course. We've done some Python scripting as well, but absolutely use those to your advantage. So we're going to hop into specifically Terraform tonight. They have a really cool getting started kind of walkthrough. We're going to start off with that, and then we're going to kind of veer off and do our own thing. But I wanted to give this all to you because it's a really good, it's a really impressive installation, and like getting started guide. It gets you started really quickly, and it really helps you to be able to break down some of the things. So after we go right, we'll stay on here for the installation and maybe for the first slide or two, and then again we're going to veer off, like I said, but you should be able to go back to this if you didn't understand or you want to dive deeper of the like super basics. You can go through this, and I think it's a very good walkthrough, and I think everyone who has a piece of software that they're trying to get people to use should take a page out of HashiCorp's book, because this is super well done. We're not going to watch this video. Cool. We are about to get started. I'm gonna get some water. Does anyone have any questions before we get started? And actually, we're making good time. I don't think this is definitely not gonna be a 3-hour night, which is good. I think I can get us out of here right at 10, which would be great, because again, I still have stuff to do. Ansible mostly uses SSH and does need Python SSH to access your servers. It was kind of fun to use. Yep. Yeah. I really do like Ansible. I wish I got to. So Ansible's the one. Ansible. I've never used Ansible or SaltStack in an actual production environment. I have both Puppet and Chef, but I've done a lot. I've done a fair amount with Ansible, and I wish. I kind of wish I see the appeal, but I don't know. To me, they all do the same thing. Terraform versus CloudFormation when dealing with specifically AWS. What's the lowdown on that? I'm a strong if you've ever used CloudFormation seriously, you'll know that Terraform is the answer. So one, there's no easy way to deploy and manage your cluster of CloudFormation templates. There are some tools out there that are crappy to allow you to do that. But by default, there's no good way to deploy them, which kind of sucks. Terraform handles all that for you. And Terraform's Terraform's easier to read and to understand, easier to learn, looks better. I don't know. Everything about Terraform is nice. The only thing that sucks, and generally you're not gonna it may suck for personal things, but it's not gonna suck for enterprise. Like if you're working for someone, is that because CloudFormation is Amazon Web Services, because it's AWS's tool, generally when Amazon releases a new service or updates to their service, generally they'll get an update out pretty quickly to CloudFormation. There's a star next to that, because they actually still have some services that there are missing features from in CloudFormation. But Terraform, you might have to wait a little bit for people to kind of get that functionality in. But now Terraform is so big, people are submitting pull requests really quick. I would, unless you have to use CloudFormation, Terraform to me is just the default now. Like, it is what you should use. I'm comfortable enough saying it's what you should use. Even if you're only using AWS, I think Terraform is the much better option for people to use. All right, let's get moving. First thing we're going to do is we're going to install Terraform. Installing Terraform is great. Why is it great? It's the same thing as most other Go packages. Terraform is, in fact, written in Go. And actually, we can go to GitHub. Like I said early on, that's one of the reasons why we did do Go, is because a lot of DevOps tooling is written in Golang, because it's great, and so you can commit things to this. You can contribute to this project. Terraform is open source, which is super nice. How does HashiCorp make money off of this? Well, they provide like a cloud and all kinds of other stuff around this. But yes, it is open source. You can contribute to it if you need to, or if you want to ever just go look at how it works. It's interesting. It's very interesting, kind of following how things work and seeing how things work. And might just help you learn Go a little bit if you want to learn Go. But because of that, they just give you an executable, which is super nice. We know that Go is a compiled language, so they can compile it down to an executable file for us and basically deliver us that. So let's go ahead and get it installed first. How do you install Terraform? You install Terraform by finding the appropriate package on your system. So I click that and downloading it. Package to zip archive. After downloading Terraform, unzip the package. Terraform runs as a single binary named Terraform. So great. So it's going to basically download a file that we can use. It's pretty easy to install on whatever your system is. So if you're following along, click this to get your appropriate package. I'm going to choose the Linux 64-bit one because that is what I'm using. I'm going to go ahead and download that to my downloads. Actually, I'm going to download it to home. I'll download it to home. And it'll go there. So, it's basically letting us know that we need to unzip it. It's going to be a binary. Just so you know, I don't know if I think we talked about it a bit in Linux, but it's a binary. So we should be able to just execute it from the command line, depending on where it is. If we want to be able to run it by name, we need to move it into our path. So that's what we're going to start out with. We just downloaded this to our home folder. And so looking here, got this Terraform thing here. And I already have Terraform installed on here, actually. It's just an executable, so actually let me remove it because it's probably old. I didn't mean that's not the one that I meant to do. What's up, Giovanag? Welcome, thank you for the follow. Welcome to the channel. So let's also remove the executable. So it's in my path. Actually, I don't know where it is. Let's see, Terraform RM, just so you can see me install it from scratch, which isn't hard. I'm basically gonna do the opposite of everything that you see me doing right now. What? All right, so I don't have Terraform installed right now, and I also removed the executable, which was a mistake. Open that back up, and let's go in here, and let's go ahead and download it again because I messed up. All right, so if you're on Linux or you're on Mac, I think it should work the same way here. So downloaded. And so now you can see that it exists right here. So let's go ahead and unzip it. How do you unzip a zip file in Linux? You just unzip and the name of the file. You might have to download unzip if you've never used it before. And it's inflating Terraform. And when we look again, we have this executable. You can see here, we can execute it. We have this executable. So I could right now run /terraform and this would work. Gives us some things, tell us how to use it. We can check version like this. But if I leave it here, I'll have to keep calling it from this location. The way that you're able to call commit, like all the tools that you use, like ls and things like that, these are simply executables that exist within your path. So you can do something like which ls to find out where ls is. So I could put it in this bin folder. If I want, and so I'll move it there, that's fine. So I'm gonna copy Terraform. I'm gonna have to do a sudo because this is a systems folder. Copy Terraform to /bin. Or you can run it from there. And then now I no longer have to do this /terraform. I can call Terraform from anywhere. And I can just type Terraform and it will read it. I basically just copied this executable into a place that my computer knew about. We talked about paths a little bit. So I wouldn't recommend fighting with your path right now. I would call it from where it's from right now if you're having some trouble with that. We can work on that later. What's up, David Borland? Thank you for the Twitch Prime sub. Welcome, welcome, welcome. Let's see here. Why would you use these configuration tools like Ansible or Puppet over console in Cade's environment? I'm actually gonna wait until the Kubernetes section for a discussion like that. Again, there's a lot of context that I think people would need to understand that. But yes, I mean, I wouldn't, but again, it all depends on your use case. There are trade-offs to everything. There are definitely trade-offs to everything. Okay. Oh, why do I keep doing that? All right. So Now I can call Terraform from anywhere, which is nice. So they let us know when we're installing Terraform. You can verify it by just typing Terraform. We saw this output already. Great. Super easy to install. Really nice. Just unzip the file, and now you've got an executable binary that you can use to be able to do some stuff. The same thing like every other Linux command. If we need help, we can do Terraform Help, and it'll tell us what to do. So really nice. We can read through this if you need to. If you read through, it kind of gives you all that. And then you can just click this nice next button down here to be able to build your infrastructure. Actually, before we get started, before we actually build this infrastructure, it's worth noting that I think we had it set up you probably had it set up already from the Lambda lab, but to be able to actually deploy this infrastructure, you will need to have your AWS CLI set up, or if you do not have your AWS CLI set up, you will need to have access to your secret key and private key. And again, I can show you how to grab that in a little bit from your IAM console to be able to import that stuff into here and for it to be able to deploy to your AWS account. Again, we're going to be building stuff with AWS because that is the cloud service that we learned. And yeah, so cool. So building infrastructure. So we're on the section now on how we can actually go ahead and build infrastructure. And even in their example, they're using AWS because AWS is great for everything. It's just big. It's used by a lot of people. But see here, Terraform can manage many providers, including multiple providers in a single configuration. So these providers, let's talk about them first. Terraform is used to create, manage, and update infrastructure resources such as physical machines, VMs, network switches, containers, and more. So you can manage a whole bunch of different things here, and we have a whole list here. Almost any infrastructure type can be represented as a resource in Terraform. A provider is responsible for understanding the API interactions and exposing resources. So what are these providers that they're talking about? These providers are packages. This is the thing that allows you to be able to interact with whatever service, or allows Terraform to be able to interact with whatever service that you're talking about. So I've said many times that AWS is just, it's a bunch of infrastructure with a layer of software sitting over top. It's just a giant API. It's all AWS is. It's really not that special. Well, it is special, but it's just a layer of software sitting over top of physical infrastructure. And these providers are basically a layer that's responsible for understanding API interaction. So understanding the AWS provider, there's a provider for AWS, which is, you can see listed right here. This provider is responsible for making sure Terraform understands how to interact with the AWS API so that it can properly provision and configure the resources that you need, which is really nice. What's good about this also is that you can write a provisioner for anything. If you want to take the time to do it, you can write a provisioner for anything, which is nice. So Terraform is great because it can be extended to use, whatever cloud provider, whatever infrastructure provisioning thing you want to use, you can do that. And you can see there's a lot of things here. There's Cisco stuff. There's so many different things that you can use here. You'll commonly hear just the cloud providers used with this, providers for just the cloud providers. Again, GCP, Microsoft Azure, and AWS. But you can see here there are a lot of other ones, and there are also a lot of experimental ones that people have written to do other things with different providers. So just want to show you that this can be used with more than just AWS. And it's up to you to find out if there's a specific tool or something that you would like to use this for. Make sure you go check out if there's a provider written, or go ahead and be the person that spearheads creating that provider. All right, let's see. Oh, y'all are rapping today. There's a lot of chat messages over here, so I'm going to skim really quick because it looks like you guys are talking to each other. All right, good convo though. Looks like there's some good convo about some important things. All right, we learned a little bit about providers. So tonight we're obviously going to be using, I said, the AWS provider, and you're gonna learn how to use that in a second. Okay. If you don't have an AWS account, go ahead and create one now, unless you know what you can do here if you need to. Hopefully you already have one set up. It gives you a little disclaimer here about what goes under the free tier and whatnot. You know, they're saying that you might be charged money. So that's nice little warning there. Probably had to do that after someone probably got mad at them for costing them money. All right, configuration. They kick you straight off with some configuration and some code that you're gonna be running. So the set of files used to describe infrastructure in Terraform is simply known as Terraform Configuration. Excellent. We're going to write out our first configuration now to launch a single AWS Ec2 instance. So that'd be great. So we've done that manually a bunch of times. So we're going to learn how to do that via code. The format of the configuration files is documented here. I will paste this to you. So let's talk about this really quick. Terraform, you might be saying, what kind of code does Terraform use? Do I need to know a certain programming language or what? The format that Terraform uses to write its configuration is called HCL, which is basically called its HashiCorp language. HashiCorp is the company that manages and created Terraform. But so you are learning, you're learning a new format of things. I wouldn't say you're learning a new language, but you are learning a new format for how to configure these things. It's very YAML JSON-esque. You can actually write this in JSON. It actually says it right here. Configuration files can be JSON. We've talked about JSON a bit, but we recommend only using JSON when the configuration is generated by a machine. I highly encourage you never to manually write any JSON. If you don't have to, write this in HCL unless it's being generated by a machine and passed to other machines. So yes, you do have some options here. So the entire configuration is shown below. We'll go over each part after. I really like that. It's been a while since I went over this. I just remember it being really good. It's nice to read through again and remember what I really liked about it. They're gonna give you the configuration, and then they're gonna ask you to run it, I think, and then they're gonna go over each piece, I think. Allow you to paste it in, allow you to get some code already up. So we're not gonna copy and paste, we're gonna type it out. But it just says save the contents to a file named example.tf. So Terraform files need to have this .tf extension, like Go files need to get the .go, Python files need the .py. .tf are Terraform files. That's how Terraform knows what it is. Verify that there are no other TF files in your directory, since Terraform loads all of them. So you got to be careful about that. You got to make sure things are in the right place. But let's go ahead and let's get going with some Terraform. So we're gonna go ahead and open up a file. They said name there is example.tf. We know we're creating an EC2 instance. I'll get a different name. The name does not matter. Let's go back down. Let's go into the right folder. We want to go into mastermind streams. Isn't there a CD serverless? Whoa. Go. What's in here? See, this feels, there's a folder with all of our, I thought we had like a whole entire DevOps thing. All right, it's fine. Go to streams. Cool. Let's we'll just move it to wherever it needs to go after. We'll make a new directory. We'll call this Terraform. All right, so in here, what we're gonna do is we're gonna go ahead and create a file. So we're gonna vim ec2.tf. We said it needs to be TF to be a Terraform file. So if you're using VS Code or something, there are Terraform extensions. I don't know how good they are. I think I have one installed inside of my Vim as well, but I don't know how good it is either, because I don't write a lot of Terraform from this computer. I actually don't write a lot of Terraform at all right now. So you can go ahead and try to install those extensions if you need them. So we're gonna be going back and forth between this And this, so let's go ahead and break down the first part. And I'll break it down while we're going over it. They'll break it down to you later. But the first part right here is the provider. So we're going to be using AWS. So we need to tell it what provider to use, so it knows how to manage the API. It knows how to interact with the API. So we're going to do provider, and we're going to specify the provider. Again, if it was Azure, we would need to call the Azure one instead or whatever. So we're gonna call a provider, call AWS, and then we're gonna do some curly braces so that we can put our configuration inside of it. So let's do that real quick. So provider, AWS, and we're gonna open and we're gonna close. All right. So we got that first piece down. All right, it says profile equals default. So we learned a little bit about this when we were setting up our AWS command line. Basically, AWS, this will probably be yours by default. If you set up your AWS CLI last time, this will work for you probably right out of the box. If you have more than one, so these profiles are something that the AWS CLI implements to basically allow you to be able to manage multiple AWS accounts from the same computer. So you can imagine that we set up our credentials once. And so like right now, if I go through and I write, and I do an AWS S3 LS to look at my S3 buckets, you can see here, I've got two different things here. You can imagine, hey, what if I have another account? This is my mastermind account. What if I want to check my personal account? How would I switch to that from the command line? Would I have to change my credentials? That seems like a lot of work. Profiles allow you to be able to do that. So I may call one mastermind. I may call one personal or something, whatever you want. But default is the way that you access the default one that is on your system. And then you can have a region here. You don't have to specify this, but it's common practice just so it spins up resources in the region that you want. So that's what we're doing here. We're just telling it what profile to use, which is my default profile. So it'll use whatever is set to my default AWS CLI profile, and it'll set the region. So we'll go ahead and we'll configure that really quick. So first thing was profile, was that equals, and it needs to be a string. And the next thing was region, and that needs to be also a string, US East-1. All right, so we have that set up the same way. Does that look the same as this? It does, in fact, minus these spaces. We're gonna talk about that in a second. But yes, we have that set up. So next block we have here is the resource. So all the things that you're going to be spinning up, well, not all the things, but most of the things that you're going to be provisioning are resources. So this resource block, you basically specify a resource, you tell it what type of resource, and then the name. And so you might be like, how do you know how to do that? I'm going to show you the documentation where you can go to understand what resources you can spin up, how to actually do it, be able to follow examples. I'm going to show you that in a second, but that's what we're doing here. Remember, we're spinning up an Ec2 instance with this tutorial. So we'll basically type this in. So resource, you have to type AWS instance if you want it to be an Ec2 instance. This is the resource name. And then this is just a name, like an alias to refer to this specific resource as, not in AWS. So like I can give this any name I want. This will not be the name of the thing inside of AWS. This is for me to identify it other places in my code if I need to. And then you have some options in here. One of them is AMI. We talked about AMI as being Amazon Machine Images. This is the base underlying operating system or image that your server is going to be spun up based on. So you can define that here, as well as the instance type. I think these are both the two required things that you need. I don't think you need anything else. Just the base image and the size. So if you want the free one, T2 micro is what you want to use. So let's go ahead and let's set that up. So we want a resource. Doing pretty good. It's AWS instance, I think. All right, AWS underscore instance, and we can call it whatever we want. And we're gonna say mastermind dash example. I don't know if we can use dashes, but it's a string, so I hope we can. So this is just our example mastermind example. Where's my dash? Instance. All right, let's go with that. Let's open up some curlies. Let's close some curlies, and let's put what we need in between. I'll show you how to find what you want. So I don't know what this AMI ID is. I don't know what it is at all. But we're gonna grab our own AMI ID. I'm gonna show you where to grab it from. And we're gonna put our instance type. So we know our instance type. I'll put this in here real quick. We know our instance type is gonna be a T2 micro. So let's go ahead and type that in, because we want it to be free. So a line for AMI and a line for instance type. All right, I'm doing pretty good with the typing. And we know we want that to be a T2.micro. All right. So AMIs, something I may not have told you about AMIs. So this is more AWS stuff for you this evening. And I told you we'd be learning more and more about AWS as we went along. But AMIs, these IDs, they are specific to each region. So the same image in another region will actually have a different ID. So let's go ahead and look at what that means. Let's look at how we can find it. So we're gonna log into AWS. Nope, this is my personal account. I need to get into the mastermind account. Not now. Sign out. Log back in. Different account. Password. I got my phone today. I do in fact have it. Hopefully it's not dead. It's not dead. Authentication code. Let's grab it. Also, something important to note. If you are ever, you won't see me do this, but these two-factor auth codes, if you'll never see me put in 2 in a row. Like if I fail to put in one, you'll never see me put in another one, because if you have 2 in a row from me, it makes it possible for you to actually crack the hash for that and to figure out what numbers might be. You can figure out the pattern. I mean, everyone can't do it, but it's possible. So just be careful if you're ever using two-factor auth for any of these things that kind of, you sends you authy things or whatever and sends you the code. If it sends you 2, like if someone gets 2 of yours in a row, they can actually crack it. So just be careful with it. But just want to throw that little bit of knowledge out there. Again, we're building, we're throwing out little tidbits, things we picked up over the years. Okay, so how do you find the AMI ID? There are lists that you can find. Amazon has lists of these things. One of the easier ways I find, at least, than combing through those lists is to simply go and act like I'm going to spin up an Ec2 instance. And I can launch an instance, and you can click on My AMIs if you had your own to get it. But we've been using Ubuntu, so we're going to keep using Ubuntu. And the AMI ID is simply right here. So just act like you're going to go spin up a new one and grab the AMI of the thing that you want. And again, this is actually different. Take a look at this. It ends in 6F4D. We changed to Ohio. And look at the same Ubuntu instance. Look at that. It is different. So again, very important that you know that AMI IDs are different based on the region that you are in. So just make sure you're using the right one, especially when you're using configuration like this. You need to make sure you're using the right one. So we're grabbing the right image ID here. So let's go ahead and put that in right here. All right. So now, just like that, we have set up some things. Set up what they have here. They've got 2 commented out items here. I think they did this just to show you that there are other options, other things for you to configure. This is not all the options. I think this is just the necessary options. Things like VPC security group IDs and subnet IDs. You have all the granularity that you have inside of the AWS console. You can go ahead and define those things here as well. But right now, all we need to do is define these things. So Everything down here is going to tell you what you need to do to be able to, like, what each of these is going to break down each of these sections and tell you a little more. Tells you more about providers. So I would go back and look deeper into the providers block. You don't have to copy in all this stuff. This is just showing you how to use a different provider and that you can use multiple providers in the same thing. So we can use AWS and Datadog in the exact same thing. And let you know about the resource blocks and initialization. So let's talk about initialization. We have our code here. We're like, all right, we're ready. Like, this is good. Terraform's going all great and everything. Everything's looking good. Let's clear this. Initialization. The first command to run for a new configuration or after checking out an existing configuration for version control. So you need to do this even if you are checking out something that's already been created. If you just check it out and clone it and bring it down, you need to run this Terraform Init command right here. So this looks like the Git one. So this is like Terraform initialize, basically short for initialize. Terraform Init. So it initializes various local settings and data that will be used by subsequent commands. So nothing crazy here. All this is doing is kind of getting everything. It's pulling down some things like it's pulling down the plugins for the providers. It's just getting things set up for you to be able to actually use Terraform in the way that it's intended to be used. So we're going to go ahead and do that. They give you a little more information about it, like that it uses a plugin-based architecture. And so let's go ahead and let's run this Terraform Init command. And so you want to be where you just created that file. We'll do Terraform Init. Initializing the backend, initializing provider plugins. So you can see here, it's downloading plugin for provider AWS, because that is in fact the provider that we said that we were going to be using. Gives us some more information, lets us know the version. Then it gives us a success message. I like Terraform a lot because of the messages that it provides when you perform actions. It's been successfully initialized. I can now begin working in Terraform. Try running Terraform plan to see any changes that are required to your infrastructure, blah, blah, blah. Bunch of other stuff. Okay, excellent. Let's see what else they have here for us. All right, we're talking about a little bit more. So first things first, let me give you a little bit of history behind Terraform. Terraform is now, basically it's kind of split. Up until version 0.11, things worked one way. And so this saying, actually, let's see what version we have. We just installed a new version, but all right. So up until 0.11, everything kind of worked in one way. Once it got to 0.12 was a major refactor to the code. It changed a lot of things about Terraform. It added a lot of creature comforts. It made HashiCorp language better. It made the way that you structured these things a lot better, a whole lot better. So here's the problem, and this is why this is a very important thing to caveat. Very important thing to note is that when you're going out and you're looking at resources for how to do this, a lot of the resources you're still going to find are going to be for versions below 12, including things like this Terraform plan. It's not something you need to do anymore. It's still available. Most of it'll still work. But it'll give you some weird output. And there are different ways to do things. I need you to be cognizant of that when you're going out and learning and you're Googling and all kinds of stuff. You'll probably see me do some things tonight that are meant for versions previous to 0.12, just because when I originally learned Terraform, that's the way I did things, but we'll try to update the way we're doing things to act accordingly if it does give us any weird output. But again, just super important to note, if you're not someone who knows Terraform, you might be confused by the Terraform plan. Again, people who are learning Terraform now probably won't be doing Terraform plan because you kind of get that out of the box with an apply. But just wanted to tell you that there was a major rewrite from 11 to 12. And luckily, most of HashiCorp's documentation lets you know that it's either for 0.11 and before or 0.12 and after, and it tells you where to go to find the other information if you need it. I still use tfplan too. I think it's nice, but you get it. You just get it out of the box. So I still do it. You can still use it. I don't think they'll ever pull it away. All right, so we initialize everything for this. Now, formatting and validating configurations. How do you know if your stuff is valid, and how do you kind of format things to make sure things are right? So, to follow style conventions, we recommend language consistency between files and modules written by different teams. The Terraform FMT command enables standardization, which automatically updates configurations in the current directory for easy readability and consistency. Where have we seen that before? Things are coming full circle now. Where have we seen it? We've seen that before when we learned Go. The FUMT package, the format.println, the format, all that. We saw that Go could automatically format your code. When you go to Go Playground and you got this format.println thing here, and you do something weird like this. You run this formatter. Well, that wouldn't work. I just broke the code. But maybe if I had, another print line somewhere else and really weird. Well, yeah. If you do this, you can click format, and it will put the code into a consistent readable state for you, so that everyone's code kind of looks the same, like formatting wise. Because this is written in Go, they've also included this functionality inside of the binary, which is really, really nice. So we can run this code. We can run that to get our stuff in a consistent state. So maybe let's take a look at it first. Take a look at it. Everything looks, doesn't look crazy. But let's, take a look. Everything's kind of got one space in between it. One space, one space, one space. All right, let's go ahead and let's run our Terraform bumped. So when you run it, it lets you know what files it makes changes to. I think you can do a dry run of this if you need to, but it lets you know that, like, if there were more than one file here, it will list out all the files it made changes to. So if I run it again, there will be no output because it's not actually making any changes to this file because it says everything is all good. But now let's take a look at it. And this is something I really like. Now look at all these spaces here, but it lines up the equal signs, which are very nice. That makes it very easy to see your key and your value. It makes it very easy for your eyes. It makes it very readable for you, the user, but it does not affect the computer. The computer can still read it just fine. So it's great. So yeah, it's super great to kind of have that available to you to make sure everything is formatted nicely. So that is all this Terraform FMT thing is, that format that you can use to do that. If you're copying configuration snippets or just want to make sure your configuration is syntactically valid and internally consistent, the built-in Terraform Validate command will check and report errors within modules, attribute names, and value types. A lot of words there to just say, if you want to know whether or not you have valid Terraform configuration, you can go ahead and you can run Terraform Validate. And it'll run through and it'll let you know whether or not it's valid. It doesn't mean it's going to do the thing that you want it to do, but it will in fact let you know that it is valid Terraform code that can be deployed. And if it's broken, we'll see broken code shortly. It will tell you what you need to fix, and it'll usually give you some kind of general help on what you need to change it to, what needs to be changed about the thing that you wrote, which is, again, really great. This is not something that CloudFormation does. CloudFormation, you write this stuff, you deploy it, it breaks, you got to log into AWS, look at the CloudFormation like events, read the arbitrary, random, unhelpful problem that it lets you know the reason why it failed to do anything, and then you got to go figure out how to fix it. Terraform is much better in that fashion. Another reason why I like that. All right, I forgot I was ignoring the chat again. Sorry. Again, it's so much weird that it's only over a little bit, but it's over just enough for me not to see it all the time. Does having a background in coding help with this stuff or not? Yes, it does. It does, because as you'll see in a second, it's not just configuration. You're not just defining some stuff. You don't need a background in coding, but it does help because there are things that there are There are loops. There are, if you need them, there are loops. There's a lot of different functionality that come from coding that helps. So it will help. You'll see that tonight as well. I like the alias. I like the alias a lot. I alias a lot of different things. All right, yeah, and the Go Bootcamp is incoming. There's going to be a bigger software bootcamp again, specifically with Go. A lot of people like to use Java to teach software or any statically typed compiled language. So if you really want to get some, if you're really looking to get some real programming chops, I highly encourage it for people in DevOps, just because the things that we're doing, we don't necessarily need to know how to make web apps, but understanding software development concepts and skills helps a lot. So we are in fact developing a specifically software bootcamp using Go. So it is incoming if you want to learn more about Go. Okay. Where are we at? So our configuration is valid. So what do you know about Terraform commands right now? You know that the files need to be have a .tf extension, which kind of makes sense. You know that once you do that, you need to run a Terraform once you got your files in place, or if you just downloaded some files, you just checked out some files, you need to run that Terraform Init command to make sure all the plugins and everything are set up for you to be able to run this stuff. You also know that you can use the Terraform format command, Terraform FMT command, to be able to get your code formatted so that it's in a consistent, readable state. And you know that you can use the Terraform Validate command to make sure that your Terraform configuration is good to go. All right, it's a lot of stuff, whole lot of stuff. So now apply your changes. And so here's the note here to talk about Terraform 11, 0.11 and above or whatever, and 0.12, all that stuff. The commands shown in this guide apply to Terraform 0.11 and above. Earlier versions require using Terraform plan commands to see the execution plan before applying it. Use Terraform version to confirm your running version. So we've already done that. We already know, we already know that we're running a version that is greater than 0.11. And so if we run our Terraform plan, we're gonna run that first. Let's check the output. So it's also letting us know here that Terraform apply actually runs a plan first before it applies. Before, you had to do a plan first, then you had to apply it. Now the apply will actually do a plan, but we'll show you that. We'll run it by itself. Terraform plan. So what does Terraform plan do? Terraform plan runs through your configuration and it determines the changes that need to happen to get your infrastructure from where it currently is into the state in which you've desired, which you've declared in your code. So let's see how it outputs that. That is like, you're like, oh, that's confusing. How does it do that? All right, so it's actually really, really, really nice. Again, this is also something that CloudFormation does not have. Okay. An execution plan has been generated and is shown below. Resource actions are indicated with the following symbols. It even has a little legend to tell you what's going on. So whenever you see a plus, these are things that are going to be created when you deploy. If there's a minus, a red minus, there's going to be things that are going to be torn down. And then there's a orange squiggly line that will be all the things that are going to be changed when you do something. So it says, hey, if you go ahead and run this, you're going to get a new AWS instance and it's going to have a new AMI and it's going to get all these other options are going to get set, but like AWS is going to basically set those for you and we won't know until you apply it. All these different things that go into an Ec2 instance. This is also really nice because this also shows you all the options you have for specifying things. So if I needed to specify anything else, like a key name, I could do that in here and it's just showing you what your options are for that. We know that Ec2 instances are backed by EBS, which is Elastic Block Storage. So you can clearly see here that it's going to create one of those too, and it's just going to create all the network interface. It's going to create all this stuff. But it lets you know that it's going to add one thing. It's going to add one resource, but in that resource, it's going to set up all these things. So these are all these are all seen as a part of this one resource. It lets us know that it's going to add one, not going to change anything, and it's not going to destroy anything either. This is a really amazing paradigm. Like, this screen is like, this Terraform plan is so good. Let's talk about how does it know how to do this? So actually doesn't know yet because there's no, so Terraform manages state, and we'll see after I run apply in this something called a state file. And that's what it generally uses to find out what the delta is. We don't have a state file, so it lets us know that, hey, you don't have any of this stuff set up, so we're gonna go ahead and set this stuff up for you. Also important to know that you can actually use this out parameter, and you can actually save this plan to a file. You can actually use these files to like, you can actually use these files for automation and to deploy changes and to version control changes. Actually, it's very interesting how you can do this, but you can do like Terraform plan out equals, and I can say like plan, I call it like plan, or most people call it what, TF plan, and I don't think I have to put an input variable there, but now I can do the plan here, and plan will save to TF plan to perform exactly these actions. Just these actions here, I could actually run apply with TF plan. So again, this is these plan files are great because you can use them to apply very specific changes to code if you need to. Again, this is not something you need to worry about right now. Just know that you can export these things to a file, and you can use these files to be able to apply specific changes at a given point in time. But we're not going to use that right now, and I'm actually going to delete this file for now. Great. Just very, very important to know. No, CloudFormation is not idempotent Terraform. It is not. What's up, Keysore6? Welcome to the channel. Thank you for the follow. It is not. Yeah, it's definitely not. So let's do what they said. Let's actually run a Terraform apply. So Terraform apply. And again, this is actually going to run a plan. It didn't used to. You had to run a plan first. Gives us the same output here. So, run a plan. It says, hey, do you want to perform these actions? Terraform will perform actions described above. Only yes will be accepted to approve. So you got to type in yes here. And when we run that, it will go through and it'll create the instance that we said, creating. Another thing to note about the difference between Terraform and AWS CloudFormation is CloudFormation, I don't know why, Terraform is much faster. Most things deploy much faster in Terraform. And I'll let you know when it's done. Again, we're spinning up a whole instance. It's only going to respond once it's done, but we can go into our EC2 dashboard. Close this. And we can see that now, actually, do I have the right thing? Am I in the right account? Hold on. Where did I? Oh, actually, I am in the wrong account. I'm in the wrong account. I need to log into my personal account because that's what we originally did the first AWS thing with, because I did not have my, I didn't have my phone that day. So I couldn't use multi-factor auth. Whack. All good. Okay, this is the one that we just spun up. I'm actually going to delete these so that we're not all confused. I'll terminate all these things. These are things that we set up last time. So you can see it's still initializing. And also just look at, we can kind of confirm this is the one that we wanted. T2 micro, we can look at the, we can look at the AMI ID, which is the Ubuntu image that we specified in there. But yeah, it doesn't have a name. Why doesn't it have a name? Didn't we specify a name? Didn't we specify a name here? Again, this name has nothing to do with AWS. This is specifically for reference. It's the name for this resource inside of Terraform. Again, if we needed to talk about this later if we needed to do this later for any reason. So now let's get into, so that was super easy. And so it took a while to kind of get originally set up, and it takes some time to understand how to figure things out. But yeah, it was pretty easy to set that up, and it was super easy to go ahead and deploy this thing. And now we have a server. Can't log into it because I don't have a key. I don't have the key for it or anything like that. It actually doesn't have a key. So you actually can't log into the server or anything right now, but we do in fact have a server. And so here's where we're going to veer off of this, and we're going to just go have some fun now. Actually, we'll do this. We'll do this actually, just to show how changes work. So, what happens if, hey, like this thing doesn't have a name, and you're like, oh man, like I really want to give it a name because I really want to be able to identify this within the console. I hate how terminated instances stick around for so long. They're like, hey, I want a name for this. Like, so you may not know this, but the name is actually just it's just a metadata tag. So that it's actually, for most things, it's a tag. And so you might be like, hey, how do I get a name? How in the world do I get a name for this? Now you can go to the provider page to kind of learn how to do that. So here's how you find the documentation on that. You can just Google Terraform, like AWS provider. So they do have a link on here somewhere. I don't want to look for it. I just think it's easier to like Google something like this. Click on it, and then we get some documentation about the AWS provider. So I've said it a bunch of times, and I still think it rings true today. Technical documentation, learning to read it and parse it properly is a skill. It takes time, but I encourage you to keep trying to use it. But it gives us some example usage on how to use this. So this is basically what we have. This is one for a basic VPC, but we have the same provider thing up top here. We can use the version, specific version if we want to use a specific version. All right. I know that I want to set up an Ec2 instance. So I can look over here to all the services you can see are listed over here on the left. And I know I want to deal with Ec2 instances. So I can read this. I can read this, and I can open this up and see if I can like find what I need. So I'm in here. I know that I want a name. I know I want an instance first off. So we spun up an AWS instance. And so in the instance section, because this is the data source that we use, the resource that we used, which is an AWS instance. Down here, you can find different arguments. So you can find different things that you can pass in and what they actually mean and what they do. So again, this is the piece that takes a while to get good at Terraform, like learning how to parse these things and learn how to implement these things properly. You can't be good, like you can't really be good at the cloud by just learning Terraform. You kind of have to understand like the things that are going on there before you can use Terraform. I know a lot of people who tried to just start using Terraform and had a lot of trouble getting set up because they didn't understand the different pieces here, like all these options. Like you can get started, you can definitely get started, you can definitely start building things, but you'll definitely run into situations where you're not sure what you need to change because you're not actually sure how to do it in the cloud. Like you're not sure what thing you need to change in the cloud. So it does take some time to get up to speed and know what to look for here. But the thing that we know is that we need, like, I know that a name is a tag and I want to add some tags. So here we got tags right here. So that seems right. That seems right. I don't know where it took us to. Instance tags. Okay. I don't know why it took us back to the top. But tags are the thing. Hey, why did that? Why did that take us? Okay, whatever. So tags is something I can use. And again, it's a similar thing to like the AMI ID the AMI that I put in. So I saw that I used it below like that. So let's go ahead and let's try to add in tags. So just for sake of time, tags itself is it can be passed in as like an array or a list, because you can have multiple tags. So whenever you need to do a list of things in HashiCorp language and HCL, you need to do it like this. Actually, move that over. You use the curly braces to kind of specify a collection of things. Think about it like a tuple. It's a tuple in Python. But I can go ahead and put a name in here, and I can set it equal to mastermind Terraform EC2. Call it whatever I want. Just a tag. Doesn't really matter. Again, I can put more tags down below if I needed to. I actually don't even think I actually think I can not use that to make it a list. But when we're actually looking at this, it says in here a mapping. It's a mapping here of assigned tags of tags assigned to the instance. So you may need to Google around how to add a tag to an EC2 instance, whatever. Again, all this configuration takes time to kind of get down. But I said I gave it a name tag here, and let's see what happens when I try to deploy now. Before I try to deploy, this was not here before the apply. When the apply happened, it creates this terraform.tf state file. This file is very, 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 very important. It needs to be there to tell Terraform what the current state of your infrastructure is. There are very interesting ways to handle this state file when a distributed team is working on infrastructure using Terraform at the same time. You kind of need to lock it and make sure people aren't making changes at the same time. It can cause tons of issues. But the state file is pretty great. I don't think we can read that either. I think it's also oh yeah, it is. So it's just a bunch of JSON or YAML JSON here that defines kind of how your stuff is, the state of everything. So you need to have that. You need to have that available, but you don't need to mess with it. When you want to make changes, after you make some changes to code, the same way that when we were learning the serverless framework, we just went ahead and deployed again. You're gonna do the same thing. So you're just gonna go ahead and do another apply. So now, what does the change look like? We created a resource previously to this, but now we are running. We're running a change. So check this out. This is really nice. An execution plan has been generated and is shown below. Resource actions are indicated with the following symbols. Remember, I told you that a squiggly line would tell you about updates, a little orange squiggly line. Terraform will perform the following actions. Basically, a change to our resource AWS instance. And you look down and you can see here that it's going to change the tags and it's going to add the name tag. So change them and add one. And nothing else. You don't see anything next to anything else. It says 0 to add, 1 to change, 0 to destroy. So again, we can be confident that our code is good. So actually, no, before we deploy that, what are some things we should do first? What did we already learn? The format. So let's take a look at our code again. Let's format it first just to make sure everything is good. And it did not make any changes to our formatting. You can see it didn't kick out anything here. And let's make sure it's valid. Terraform Validate before we run it. And again, it's valid. I actually think it would have failed when I did the apply if it was not valid. But let's go ahead and apply. And let's go ahead and accept these changes. So this is how a change works. It's also worth noting that it says update in place. So this is very, very important, knowing things that can be updated in place and things that cannot. Things that can be updated in place are things, again, like these tags. Things that don't have to, a server doesn't have to be re-provisioned to get in place. So other things that other changes that would cause something different than an update in place. If we change the AMI, if we change the underlying operating system in which this was deployed off of, that would not be an update in place. It would not be able to just update this thing in place. It would actually have to provision a brand new resource and destroy the old one. So it'll let you know when it's going to do that rather than an update in place. So updates in place can happen with no downtime. So we're just gonna say yes. and we're gonna accept that and let that go through and modify. Happens super fast, 1 change, 0 destroyed. And if we go in here and we refresh, we now have a name here, a name tag that we had in there. So super easy, super simple. We're able to go through and add in a name for that. Any questions so far? Be careful with the TF dog. Some of the examples are bad. Agreed. That's most documentation. Some of the examples are bad. I think they're pretty good about letting you know when. I think their examples are good for the basics. They are very bad for when you really need to get other stuff done. But yeah. The links in the doc, I find them to be good when they're trying to show you the difference between the version 0.11 and 12 and up stuff. I think it's good. So if you remove your file from your project, is it ruined? That doesn't sound great. Yes. Basically, it can. Yes. It might not mess us up too bad right now. But yes, you need that TF state file is very important. And they talk about it. They definitely talk about it in here somewhere. Apply changes. Yeah, they talk about it in here somewhere, but it is very important. Don't mess with it. Leave it alone. Definitely leave it alone. Let's see. Will just show the stuff that's deployed. It's not a big deal. Okay. Great. So how can multiple people work together if you need to share the file? Oh, great question. So, great question. There's a paradigm of Terraform state file locking. So basically, you can there's a bunch of different methods for this. A lot of people use things like Dynamo, S3 buckets, but basically you can you can set it up in your workflow that it checks in with the kind of source of truth wherever the truth of the state file actually lives. You basically define a place for it, and when you go ahead and run it, it'll basically check in, and if you can go ahead and make your changes, it'll lock this file for you, so no one can mess with it. And when other people try to check in, it'll basically say, hey, like you can't do anything because this file is currently locked. There are changes being made to this, or there are updates that are being made, so you can't run this. So it's a safety net. You do have to do a little bit of work to get it set up properly. I've seen it done in like 5 different ways. There are a few different ways to do it. But yeah, so you can work in this no problem. It all comes down to deploy time. Like you can work in the files easily. So like if you're an organization that only deploys through some kind of CI pipeline, then you don't really have to worry about it quite as much because none of you is actually deploying the code. It's all running through this pipeline that will handle it for you. So you're not really worried about your local state file. But yes, a big project in Terraform, it's not true at all. This is a common paradigm. It's a version control paradigm, which I think we've solved. But yeah, use S3 buckets for shared state. This is an issue that's been solved. Big teams are doing this again, and bigger teams are probably doing all this through some kind of pipeline where you don't really have to worry about it. You're generally not going to be not generally. Well, if you're in a big team, I doubt you're going to be manually deploying any of your Terraform anywhere, to be 100% honest with you. So it shouldn't really matter. It'll get created throughout that CI process. Okay, so we learned the basics of Terraform. So you can, because of what we set up so far, you can kind of see how if we want to spin up a new resource, again, like an S3 bucket, we can go back to the documentation, and we can go down and we can find S3, and we can see here in the example, okay, we want an S3 bucket. Maybe we just create something like this. This is Route 53 record. That's a weird, that's odd. That's okay. You're right. Bucket object, canonical user ID. Oh, resources. I clicked on the wrong thing. S3 bucket, you know, if you want to set up an S3 bucket, you can set it up like this. So you can kind of see how you can just add resources and stuff if you wanted. So, knowing that, you might also think, actually, before we do that, let's talk about how now configuration management infrastructure as code is much bigger than just defining these things. That's great, but there is some logic that comes into this as well. So I'm gonna show you how we get into that. We do have things like variables. We do have functions. We do have loops. We have all kinds of stuff that we can use to make this better. One important thing to know about Terraform is a declarative configuration language. It's declarative as opposed to imperative. So what does that mean? That means that in Terraform, you kind of state the way you want things to be. You kind of just declare, you say, hey, I want an AWS instance with these things in it. But you don't really tell Terraform how to do it though. Like, you don't tell step by step what to do. You kind of just say the things that you need, and Terraform is created in a way that it knows how to go through and give you what you desire, as opposed to something that's imperative, which would say, hey, all right, give me, like, in order, give me this, spin down this, spin up this, you need to do this next. You're not giving it the steps in order. So because of that, that allows us to do, again, it allows us to do a lot of cool things, a lot of automation to kind of get more out of this. So first thing we're gonna learn about is variables. I could put variables here, but variables are usually held in a different file. There are actually two different files. There's a vars file and a tf vars file. We're not gonna talk about that right now because that can be confusing. We're just gonna talk about how to use variables. So why would you want to use a variable? Using variables allows these templates to be reusable for different environments. Different people can use these. It makes them extensible for me to be able to pass to someone else who needs to be able to pass in different configuration. So variables are cool. So here's what we're gonna do. Nerd tree, how do you create a new thing? Add node, vars.tf. Open up a new file called vars.tf here. All right, so we have a variables file here, and here's what we're going to do. We're going to set up variables for the things that can change, which is really everything. But we'll go ahead and just some of the common things people will do is like your region. The region people will set up. So variables are set up like this. You specify a variable, and you give it the name. So the variable here we're going to call the actual variable region. And then we're gonna give it a default value. I'm not gonna talk about default values versus non-default values right now. You can basically pass in values, but default value for this is going to be US East 1. All right, so that's one variable we have here. How do we actually tell the Terraform file to, use this variable? We tell it to use this variable. I don't think I'm using anything, so that matters. Tell it to use it by doing this. You used to have to, I don't think you have to do this anymore. We'll see. You used to have to interpolate the variable because this is a string. What is interpolation? What is string interpolation? It is the process of combining strings together end to end. So you used to have to do this. I'll have to say var dot and then the name of the variable that I wanted. So it'll be this var dot region. So this will basically know to use this file because I created a variable. It'll all get loaded in, and it will know to grab the variable that is of region. Oh, the region variable here. Yes, let me save this as well. And let me run this. Let me run a Terraform plan. It shouldn't change anything because I didn't change anything, but we are going to get an error here. We are going to get an error here because it looks like, I know that this changed. So I think I just have to pull off. The these things. Terraform 0.11 earlier, all consistent expressions. Yeah, I think I can just pull this off and it'll work just fine. Basically, do I need the quotes? I never remember if I need the quotes or not. I'm gonna pull them all. I'm gonna pull everything off. I didn't mean to do that. And argument block definition is required here. So let me know there's an error here. Line 13 in provider AWS. Oh, I lost the final closing bracket here for that. I keep doing that. Just it's muscle memory. I'm trying to leave it up so that I don't have to keep making this view. All right, so another plan. All right, so it says no changes, nothing need to be updated. Everything's up to date because I actually didn't change anything. All I did was made this to use a variable rather than hard coded. So we can use this variable to do a lot of other things. So other common things to do this with are things like the AMI. So I can say variable, and I can call it anything I want. This is just it's a variable, so I can say RAMI or whatever. But I'll say variable like I'll say, just so you can see this, a variable mastermind AMI. I actually don't know if I can do a dash like that. I'll do underscore. Variable mastermind AMI, and I'll set the default to I need to grab it. Not in. Okay, so now I have my AMI here. And so the same way that we did that before, we're gonna go ahead and change this so that it uses the AMI instead. We can do var dot what do we call this? We called it mastermind AMI. Okay, that's great. Let's do it with everything here. Let's do it with everything here. So var. We don't have a variable for this yet, but we'll create one called instance type, which again is the same thing that's there. We'll leave the tag. We'll leave the tag alone right now. So we'll just do it for those three things. Let's create one more variable. We'll call we have to call it instance type. Actually, let's change it to, so it's like AMI, we'll change it to mastermind underscore instance. Okay. So now you can kind of just see here how we're using these variables here. Super nice, super simple. You basically have another file, another Terraform file. And the same way that we're specifying a resource, we're basically just setting up a variable here. And we're saying, use these variables in place. The way that you call these variables is var dot and the name. This needs to be in the same kind of directory that your main Terraform file that you're deploying is in. And yes, and this should work. So to make sure it works, let's just save both files. And again, let's do another Terraform plan. We didn't change anything, so we shouldn't need to do anything. Oh, wait, did one change? There is a change. Oh, whoops. We made a mistake here. See, and this is why Terraform is really great. Made a change here. Basically, I copied and pasted that block, and the instance type, this is actually an incorrect instance type, but I copied and pasted that block. That wasn't right. So this is great. The Terraform plan showed us before we actually ran anything what was going to happen. So that's great. We don't want to do that, obviously. So let's go ahead and fix this, because the instance The mastermind instance is a t2.micro. Ah, shoot. Okay. Let's save this. Ah, it's the same file. All right, make sure both of them are saved. Now Terraform Plan shouldn't do anything because everything should be set up right. All right, cool. So we just use variables instead of hard coding things. All good. Now, let me with the time that we have left, let me show you some other cool stuff with this. So you have variables, but what if we wanted more than one instance? Let's say we wanted 4 instances. Yeah, what do we want 4 instances? It's kind of just as what's happening here. It's kind of just as easy as copying this and going through. Oops, and you can paste. Whoa, undo. You could paste. So you could do this. And I'll run a plan. I'll change the name really quick because they have these names have to be different. Example 2. I'll make this one a 1. Oh, undo. I'll make this 1, 2. I can make this 3, and I can make this 4. And I would need to change these tags as well if I wanted, but I'm not gonna do that. I could do this. This is absolutely a way that you could deploy some things. And if I actually save this, darn it, muscle memory, bad muscle memory, bad. So run a plan again. It's going to let me know that it's going to spin up 3 servers. It's going to say, hey, I see 3 more things that we can do here. Actually 4 to add, 1 to destroy. Why is it going to? This is great. So why is it going to destroy 1? And why is it going to create 4 when I only added 3? So first thing, it's going to destroy the one that we already set up. Why is it going to destroy the one that we already set up? It's because I changed what the resource was called. It's going to destroy this one because there's no record of that anymore. It's going to pull down all of this stuff. Then it's going to go ahead and create this one, which is the one that I added. So it's going to be replacing this. So that's what you should be looking out for things that are going to be destroyed. So this is not a change. It's not an in-place upgrade. It is a destroy and recreate. So I'm going to destroy that, and then it's going to create 4 instances after this, 1 through 4. So we could do that, and that would be fine, completely fine to do. But you don't need to do that at all. You don't need to do that at all. These instances have something called, I actually think there's a whole different resource for this now, but I don't think there used to be. EC2 resources, EC2 AWS, what was it? AWS instance. Cool. These have something called, oh, it's not here. They have or count. I don't know where this is listed at. This must be for more than just EC2 instances, which I'm pretty sure it is. But they have a feature called count. So you can actually tell it. How many servers you want. So if you wanted 4 of the exact same servers that didn't really have any changes, let's take away this one for now, and let's go count equals, let's say equals 4, and let's see what happens when we run this. Don't exit. All right, so now we already have one that is up. We've already got one up, but it's gonna add 3 more. Why is it gonna add 3 more? Because again, we're not changing that first one like we did last time. We left the name the same, but it's letting us know that it's going to add 3 more instances here, and that will work. So you can very easily add some instances. The problem with this, though, there's a problem with this. You can do this. It will work just fine. But a lot of the times, so like this, you won't be able to give them, they'll all be spun up with this same tag, and they won't be able to tell them apart. You won't be able to identify them as opposed to anything else. So what you can do is you can actually use some cool functions and things inside of here to be able to do something like this better. Again, this will work. This will work no problem. It'll give you exactly what you wanted. It'll give you those 4 servers again that all are exactly the same. But maybe you want to identify them. Maybe there are some things that you actually want to change about them. Maybe there's some differences each of them need. So you can set up variables of some variables we list. They can be a collection of things, and you can actually iterate through those things. And you can also do basically loops in here. You can also iterate through these things as well. So how would you do this? Let's set that up. So basically, what if we want this? What if we want 4 instances like this? So maybe we want to call these the just to make a little more sense when someone else is checking these things out. Maybe we're going to call these mastermind web servers, just to identify them in here. But we want to change the name. We want to know that we have 4 of them. Yeah, so we could actually define the names. Actually find the names in here. So we could actually say, we could actually set up a variable called, we can call them web servers. So we can make a list of all the web servers that we want spun up, of all of them. Yeah, all the stuff we want spun up here. Now, all of these here are just strings. We set a default value. We're going to do the same thing here, but if you're doing more than just an individual item, you need to tell it, you have to tell it what type you're going to kind of give it. So there's a variable type option here that you can do. And it used to be like, you used to do like type equals list, I believe. I think list had to be in, I think this is how it used to be done. So if you're using like 0.11 or you're used to doing this, it would have to be something like this. I'm going to show you how that differs now. And actually, it's going to give me an error. So I want you to see the error and we'll change it. But default value, you can pass this in as a list of things. I think it's square brackets. I think it's square brackets. If not, I'll change it in a second. But you go ahead and I say, hey, I want my first server to be called let's call it Master Web 1. Very simple name. All of them are separated by commas. I think I can do it in this format. We'll see. I'll format it after this. Whoa. Oh, Master Web 1. Let's just copy this. Undo. What? Why am I struggling so bad right now? I am struggling. I'm really struggling. Tab, paste. Let's change this to 2, 3, and 4. All right, so we have the list of our web servers, which we would like to use. We'd like to give them different names. Again, you could call them whatever you wanted. No big deal there. But we are gonna call them Master Web 1, 2, 3, and 4. Okay, so we have this variable. How do we use this variable? How do we use this now? So let's go back over to our provider over here, or our resource over here. So we say we want 4. And that's great. That's great. What would happen if we went at 5? So if we went at 5 and we were like, oh, let's go ahead and add in a name. Let's say we went over here and we added in, another one for 5. Even though we haven't told it how to use these things yet, we can already see that this will be weird because it's only 4 here. It's only 4 here. So think about that for a second. But let's go ahead and tell it how to use these tags first. We want it to have these tags. So how do we do that? So we do know that normally we would do something like this, like var dot web servers. We call this list web servers, web underscore servers. And so that would be interesting. It's like, but how do I select which one is in there? How do I select which one's in there? Normally, we talked about learning loops. One of the loops, we know that we can use indexes and loops. You may want to say like, hey, I could use the index here basically, but how do I know what index I'm at? How do these loopings work? So that count actually initiates a loop basically, but I don't think this will work. This actually might work, but I'm pretty sure that wouldn't work. That's not how you want to do it. You need to use a built-in function for Terraform. So Terraform has these functions. Terraform functions. And there's a bunch of them that do all kinds of different things. All kinds of different things that you might be used to, splitting things. So again, this is where it kind of goes back to if you have a software background. If you have a software background, this will help because you might be thinking this way already. I think people who are coming from an infrastructure background, not being familiar with these things, you may not think about even what to look for because these are a little bit different. But if you were in this position, you would probably just Google loop. How do I loop in Terraform? Things like that. Which you would end up coming across. Well, we know we're dealing with a collection. We're dealing with this list of web server names. We're doing a collection. You go through and just for the sake of time, element is the one that we're going to want here. So element retrieves a single element from a list. So that's what we need to do. We need to get one item. We need to get one individual item out of this list each time this runs. How do we do that? Again, take you back to your Go days. This is a function. It takes in 2 parameters, 2 arguments. It takes in a list. So we already have our list, which is this web servers thing. So it already looks like we're specifying the list here. But then it also takes in an index. So let's just set this up first. So you use it just like this. You use it just like it's a function. So you do element. And then we pass in var.webservers as our first option. But we don't actually know how to pass in our index yet. When you're first learning, you might type in index because that's what it says here. But it gives you some examples and it passes in actual numbers. But how do we know? How can we refer to the number of loop that we're on? The way that you do that is actually count.index. So our count actually has a method in it of index, which will modify that number or will represent that number. This would work. This should work right here. But again, we have another problem that we talked about before. We want to make these templates as reusable as possible. We want to be able to use them outside of the paradigm in which, we don't want to just code it to do just one thing. We want it to be able to extend it very easily. So if we left it as is, because I made this 5 web servers here, I would have to actually go into this file and I would have to change this to 5. And every time I added a new web server into the pool or something, I'd have to change it here and I'd have to change it here. And we don't want to have to do that. We want to be able to just change it in one place, which is ideally here because we're setting the name here. So how can we do that? These have actually, if we went to the numeric, I believe in the numeric functions, we actually have, maybe it's in the collection function. We have length. We have the length function. Determine the length of a given list, map, or string. We're using a list. So we can actually determine, before this runs, we can set our count equal to however many items are in this list. That's what we'll do here. We'll do the length of var dot web servers. All right, so basically our count is now equal to however long this is. That's going to start a loop basically. And so it's going to run it that many times. So there are 5 items, it's going to run it 5 times. And every time it gets here, it's going to determine that the name tag is equal to this list at this index. So on the 0 run, it'll pick this first item. On the first run, it'll pick the second item. Third run, third item. I mean, yeah, you know what I mean. Third run, second item, whatever. It'll go through and it'll just iterate through this list here to give things proper names. So let's go ahead and let's see if all these changes work. So let's save this. Let's go over. Let's save this. We're probably gonna have some problems, but how can we check that? First, let's go Terraform format. All right, so it lets us know that it changed one file, made it a little bit nicer. FG, cool. Made that a little bit better. And then if we do Terraform Validate, we can make sure we have valid code. So important to know the difference between a warning and an error. A warning means like, hey, I ran into something that I don't love, but it's not gonna break. Just wanted to let you know about it. And so you can see I got this warning here, but I also got a success message. And it lets us know, hey, it's valid, but there's some warning shown above. Again, this right here is an issue, not an issue, but a difference between Terraform 11 and up. And again, that's why I wanted you to see this error or this warning, because now you display this a little bit differently. And you do it like this instead of setting the type. Instead of setting the type of this variable equal to type equals list, this is how you would have done it before. You basically set the type. You basically set it to a list and the type of list, which is a list of strings. So this is very harken back to, again, Go. I'm letting it know that the type of this is a list of strings. Oh, it's just string and not string. List strings. All right. So let's validate it again. Whoops. Oh, whoops. That was dumb. I need to still set it equal to the type. I don't know why I did that. Yes, I think this is better. You still have to set it to the equal to the type, but the value is not the string of list. It is list string, I believe. Validate again. Now we've cleared all of our warnings, all of our errors, and now we can go ahead and try to apply this. So, again, we didn't change our code very much, but we added a lot of value. So we added a count so it can loop through. And we're hopefully going to be looping through each of the tags here. And we can check that with a Terraform plan so that we know if our stuff is proper. All right, it's going to add 5, change 0, destroy 1. We know we need 5 servers. We know we specify 5 servers. You might say, hey, why is it going to destroy 1? It's going to destroy 1 because of the, that is interesting. I assumed it wouldn't be destroyed because we only changed the, didn't we only change the tag? I don't know. I thought a tag could be updated in place, but whatever. It's going to destroy it. It's going to destroy that server that we already spun up. And then it's going to spin up this one. And we can see here, in here in the thing that the first one is going to get master web 1. We scroll down to the next one it's going to create. It's going to get master web 2. Down some more. master web 3, 4, and 5. And that looks good to me. So I'm gonna go ahead and I'm gonna go ahead and type in, oh, whoops. I'm gonna type in apply. I wanna see this. I wanna see this actually work. Yep, I definitely did the count thing. So, and just like that, it's gonna say creating, gonna take a little bit of time, which changes the name of the resource. Does it? Oh, yes, it does. It changes the name of the resource for the index. That makes sense. Yep, thank you. Thank you very much, Thug Muffin. You are right. Cause a name, yeah, I just know that a tag change doesn't require, it can do an in-place update on that. So thank you for that. So creating runs through, we can, check out our AWS and we can see that now if I refresh, look at that. We got 5 web servers up and running just like that. Can you automate this with DNS2, add IP to cloud? Yes, absolutely. You can absolutely do all of those things. 100%. And I actually think there's a provider. If you're using Cloudflare, I think there's a Cloudflare provider. All providers. Yeah, Cloudflare provider. You could, if you're using Cloudflare, you could do that. If you're using Route 53, you could modify DNS accordingly there. But yes, that is what makes it so attractive. Like you can integrate it with so many different things. And again, it does take time to start thinking about infrastructure in a different way, like in an automated fashion, like this. Whoops, I didn't mean to do that. It's different. It's a different way of kind of doing things, and it takes a while to kind of learn the tools that you have available to you. But the amount of how easy it is to automate large scale, it takes some time. So a web server, or maybe there's a piece of infrastructure that may take you, if you, let's say you were assigned this work, and if you had to do it manually, you could probably spin it up, and take a day and you can get this stuff spun up. It may take you 2 days to figure out the proper Terraform code, 2 or 3 days to figure out the proper Terraform code. But now you have a reliable piece of infrastructure that can be ingrained into your process. And I'm actually going to show you how to tear stuff down, but you can also use this to, again, it's consistent, it's reliable. If you do it right, you can tear down all your stuff and spin it back up over somewhere else. Maybe you need to put it in a new region. You can do it somewhere else. It makes it so easy. I could literally go into this, I could go into my vars file, and let's say the entirety of US East 1 went down. Watch this. US East 1 goes down. Check this out. I can go to US, I can just change my variable to US East 2 if I needed to. And I could plan this out, and I could immediately, if I did this right, I could basically spin up 5 more servers in US East 2, just like that. Just by changing one thing, I could spin this up somewhere else. So it's really, really nice to be able to do something like that. Now, also, what this is good for, I think Terraform is something great for you to use while you're learning both Terraform and AWS, especially if you're learning different AWS resources right now, you can kill 2 birds with 1 stone by, again, writing out the thing to provision the infrastructure that you need, but you can also use it to control your costs. So I can, let me change my variables back to US East 1. But let's say I was messing with these web servers. Let's say I was, I installed some things on them. I was, trying to put them behind load balancers, learning different things, running through stuff. And, when I'm done with them at the end of the day, but I know let's say tomorrow I need to do some stuff again, but right now I don't need them. I could simply do a Terraform destroy. And this will tear down everything for me. So again, I can use it to manage all this infrastructure with whatever I want to do with it, which is super duper nice. And so from now on, we'll probably, depending on time, we'll probably be using Terraform to spin up the resources that we need to go over the stuff that we need. Like we're going to be, we're going to learn Ansible next, but then we're going to get into containers and stuff, and we'll spin up our server that's going to have Docker and stuff. Well, actually, I might do that locally, but anytime we need to spin up some infrastructure, we'll probably just do it in Terraform really quick for us to use, just so we have it and it's reusable. We can spin it up and tear it down. Could do a module 2, which is cool. You just pass a couple of values, yes, and create a bunch of resources. This is very true. So all of data off cluster. Yeah. Say username and things like that. Yes. Yes. Configuration data, externalized config data. That's true. But you can set all that stuff up there. Less spaghetti internet connection, I think will be less breaking. Yeah, and so honestly, for things like you're talking about, like usernames and stuff, that's generally something you would handle. So that's generally something you would handle with a configuration management tool, or you could handle it with like user data here. But yeah, that would be something a little easier, a little more easily handled with something like, again, like Ansible or something, which we'll learn. So this is provisioning the infrastructure. Ansible will basically be, after we spun up these 5 servers, we could basically use Ansible then to automatically configure those servers in the way that we wanted. So that's how you can kind of use these things in tandem to completely automate your infrastructure. You can actually never have to get hands-on with these things. You just write your configuration files that look, it takes a little while to get used to, but like they're not wild. Like this is not, I don't think this is super crazy. What's up, Willie and F? Welcome to the channel. Thank you for the follow. But I don't know. I at first this was overwhelming to me, but I also think what helped me too is that I learned CloudFormation first, and I'll tell you, CloudFormation is extra overwhelming. It's YAML. It's pretty overwhelming. Very overwhelming. So yes, any questions about the things that we've gone over, any questions about Terraform? Again, this is a very high level thing, but we will dive, again, we're gonna be using Terraform throughout the rest of the course. When we're provisioning new things, we'll go ahead and we'll set up those things in Terraform. We can start building out a little bit of a repo as we're building out more and more things. So you'll learn a little bit more, but I just want to give you enough that you can dive into it, give you enough so that when someone talks to you about Terraform or asks you about Terraform, you understand what it does, what problems it solves, and be able to talk about it a bit. Know that there's a big change between Terraform 11 and 12. Like Terraform 0.12 is where a big change happened. That might be a good talking point. Again, in an interview or something. That could help, just knowing that you can say, hey, I don't know much about Terraform. I think now's the time to get in since they just made that big change. I know they made a significant change from, when they went to 0.12 and, now I'm hopping into it. Or I don't know, it gives you a lot of talking points to kind of know what it does, what problems it solves, and just kind of have seeing it in action, I think is valuable. And this alone, I'm telling you, this alone can help you get a job just knowing how it solves problems. It also makes it a lot easier to learn. When you know what the tool does and what problems it solves, it makes it so much easier to learn. What's up, Vape Juice Jordan, with a gigantic raid. Wow. Now I got to stay on even longer and talk about what we've done. I also am going to take a minute or so because I know everyone gets hit with the ad when they first join. Bisco, welcome. Thank you for the follow. This is a big rate. This is, 99. I've never been, I'm not sure I've ever been this high before. That pre-roll ad is rough. I know. I'm sorry. I'm going to let it ride. But welcome. Tonight we were just doing a little bit of Terraform. So anyone new? What's up, IT Wobbles? If anyone doesn't know what Terraform is, I'm sorry. I still haven't disabled. You can't chat. I'm very sorry that people can't chat. Actually, I don't know if I can turn followers only chat off. But yes, we made it triple digits. That's awesome. Thank you, Babe Juice Jordan. What were you guys doing tonight? I know I've been watching you for the past few nights. What you guys been doing tonight? But yeah, just a little bit more about what we're doing, everyone. All the new folks. We're in the middle of a DevOps boot camp. So what is DevOps? DevOps is just a culture, a methodology for developing software and delivering software quickly. It's enabled by tooling, so a lot of people, think about the tooling. But yeah, it's kind of morphed into a couple different things. It's kind of a systems administrator using the cloud, and it heavily relies on automation. I think of it a little more than that. I actually think the job is, being the arbiter for the developer, helping the developers develop code as fast as they want to, putting in processes and putting in pipelines for developers to get code where they need it to go as fast as possible. So we've been learning a lot of stuff. You can head over to academy.mastermind.io if you want to know a little bit more about what we've been doing and kind of what we're going to be doing. And I'll share this in the chat. But yeah, we've gone through a lot of stuff. We've gone through some Golang stuff, introduction to programming, some Linux stuff, networking and security, web servers and traffic management, AWS stuff. We learned a lot about the cloud over the past 2 weeks. And now we're in the configuration management. We're learning about Terraform tonight. How do you write code to provision and manage infrastructure assets? And we're gonna learn about Ansible on Wednesday, today's Sunday, on Tuesday, if you're interested in that. Thank you for the follow, everyone. Use all the things. Appreciate it. But we're gonna dive into containers and a few more things. So we just started week 8 of the 12-week course. So we're getting near the end, but you can check this out. But we also do a Python bootcamp. The Python bootcamp is on Mondays and Wednesdays, and this is an introduction to coding with Python. We're just getting into object-oriented programming this week. So all week we'll be spending time with classes and learning how to use objects and learn about different paradigms in object-oriented programming. So that was a big intro to the channel. Thank you again, Vape Juice Jordan, for bringing everyone over. I do genuinely appreciate it. Unfortunately, we are at the end. I'll stick around for a little while. We've kind of done everything that we're going to do tonight. Usually we stream from 8 to around 10 or so 8 Eastern time. The DevOps one generally takes a little bit longer. I promise you, when we get to the container section, the Kubernetes section, those will be 3-hour streams for sure. But yeah. Oh, so you guys did you decide to go with Terraform versus CloudFormation because it's cloud agnostic nature? So cloud agnostic is a fake buzzword. But yes, because it works with more than just AWS is one reason we decided to do it. Also because I think it's easier to learn and has many more palatable features than CloudFormation uses. I also think more people are using Terraform, like job-wise. I think more people are using Terraform than CloudFormation. I use CloudFormation every day. I actually dislike it a lot. And again, it is AWS only. I think Terraform is kind of becoming the standard tool for this. And that's the reason we went with Terraform for this. WordPress is dope. I like WordPress. Well, I actually don't like many relational database backed content management systems. Because I've had to manage them and it causes me problems. Right now, every day I get heartburn because I deal with Drupal. I deal with 2 different instances of Drupal, both a Drupal 7 and a Drupal 8 instance. Very annoying, very frustrating. But yeah, WordPress is good. Headless. Oh yeah, were you guys doing some? Okay, I mean. Hey, he's definitely just trolling. Gotcha. Well, I mean, if you want to know about headless CMSs, I've spent the past 3 years. That's the project that I work on. I told you guys I'm a technical lead at a software company in Baltimore, but I help. The contract that I'm on, we manage the small business administration. So the administration that helps small businesses get off the ground and gives them resources. But that is exactly what we spent the past 3 years developing, which is basically we developed a headless React, Node React, Drupal CMS. So it's pretty cool. It's a pretty interesting thing. I'll actually see how much of it I can share. It's actually, the front end is actually open source. I'm not sure if anyone would ever want it, but It's actually not only is the front end open source, our project has actually open sourced a bunch of some Terraform modules and some other stuff. Let me see if I can find it really quick. Maybe I'll show it to you guys one day. It is pretty cool. It's actually users. How do I search? What is it? This is bad that I can't find it. US SBA, that feels right. Users, there we go. Katana, this is the, Katana is the application, is the main thing that you see when you go to sba.gov. It consumes, it's a very interesting setup. I would love to talk about the architecture. I'll find out if I can talk about the architecture. I'm pretty sure I can, but I think it'll be very interesting, especially in terms of DevOps, to learn for you guys to see what something like this looks like and kind of where we went to where we are now. I think we're doing a talk at DevOps Days about it, or we put it in or something. We'll see. Good old PHP. Yeah, I mean, I super glad I teach people. I love to, I think tech can be the great equalizer. I think that all the information's out here, like having some structure around it, I think helps. I love being able to like tech has done a lot for me. I love being able to share it. That's kind of why I do it. I just love being able to share what I've learned and help people who are trying to get into it just because like there's so many jobs for it right now. There's so much opportunity for it, and like being able to I actually like the skills because it can allow me to do, like, if I have an idea or something I want to work on, I can go create it, myself. You pick up the skills, you can go create it yourself. It's super dope. But yeah, WordPress is cool stuff. I do like free and open source software. Huge advocate. That's why you see me here using this Linux laptop, the System 76 computer. I'm a big free and open source person. The only reason I do use Windows to play games and to stream off of, just because I have like an Elgato Stream Deck and some other things that just don't work in Linux. So Linux still has a way to go, but I do like free and open source software when I can use it. The word tech lead is forever burnt. Yeah, because of the YouTuber. Yeah, he's become infamous lately. Yeah, I agree. I definitely agree. He's a wild guy. He makes much more money than I do, though. His $500,000 from Facebook. Well, maybe not anymore since he's unemployed, but I'm sure he's getting that YouTube money. Maybe one day, if I can actually start pushing some YouTube videos out, maybe I can make some YouTube money. But YouTube is significantly harder than video editing. I actually enjoy video editing. I'm pretty creative. So I have a lot of fun video editing, but it is very difficult to get exactly what you want. And I don't have the equipment to get exactly what I want. And it's time consuming, and I don't know. There's so much more that goes into it. But there's a lot coming down the pipeline, which will enable exactly that. So I do hope to get some more of that stuff up. Yeah, join that Algo Pro. Is it Algo Pro or is it Algo Expert? I never know. I think Algo Expert is the regular one. Algo Pro is the copied shoddy version. Yeah. I definitely plan on doing that, an editor, but I do want to get I do want to get a feel around the things that I'm doing first, before I have someone else doing all of it, or some of it. But yeah, it does take a massive amount of work, for sure. I'll definitely find some people to help out. I've already talked to some college creatives who would be willing to intern. Maryland. So for anyone who doesn't know, I'm in Baltimore. Maryland actually offers they have a Maryland technical internship program, where they'll actually refund half of a qualified intern's pay. So I'm actually planning on hiring some interns to do a couple of different things, more than just design work and things like that, but actually to intern to learn. I'm messing around with almost live streaming the process of having interns work on some real projects, getting some projects from a couple of people, and basically paying some interns to get great. I just think it'll be fun. I think it'll be utilizing the platform for something cool. I don't know. I think it'll be fun to do that. Maybe I could use that for some of that YouTube content. We'll see. A lot of cool stuff. And again, I think there's some stuff coming down the pipe that's going to enable more of this. The problem is right now I do still work full time. So I still do work full time for a software company, which makes it tough. For people who don't know, also, if you're new, if you're somebody from the raid, I'm currently actually in a business incubator. That's the whole reason I even started doing this, because I'm in a business incubator, kind of a business incubator that helped me do the thing that I'm passionate about. When I joined it, I actually didn't even know that I wanted to start a business. So this has been a fun process so far. But because of that, it requires me to do some things, including not have a full-time job anymore sometime this year. So sometime this year, I actually will be going into this full-time. But this also isn't the only piece of it. You might be asking like, how can you live off of just doing trainings on Twitch? This is part of it. And this is free. You do get some extra stuff if you subscribe. You'll get access to Google Classroom that has some extra things, and access to like, what's that thing called? Discord and stuff. There'll be more added to that later when I have time to add things, to make that offer greater. But this will always be free. The training will always happen. This is a significant part of my business model. The other piece is engineering advocacy. So if you're an engineer looking for a job, looking to grow, the goal is going to be working with companies to really help vet, not vet the best engineers, but to advocate for people learning, to advocate to basically tell companies that like, hey, I understand what you're trying to do here. You don't need a 10x engineer to manage your website. You don't need someone with 10 years of experience to do this new thing that you're trying to do. You can do it with this person who has 3 years of experience, 2 years of experience. They just went through a boot camp. Like they have the aptitude, they have the skills. So yeah, we're just engineering advocacy, and bridging that gap. I think there's a huge middle gap right now between companies and the people out there. I think it's an adversarial gap as well. And I don't know, doing what I can to kind of change that. It's very frustrating to me. So yeah. Multi-tenant architecture with DevOps. Yeah. It's not covered a lot. And that's good. I'm actually going to copy that down. So another thing, just to keep you guys aware, when I'm no longer working when I have more time, I'll actually be streaming more, and we'll be diving into deeper concepts about everything. So there will be these long boot camps still running, but there will also be very specific things like multi-tenant architecture, like that we'll have very often as well. So like every week there'll be 2 or 3, very specific, 1 or 2 day workshops on specific topics and things like that. So there's going to be a lot of content coming out of this, when I soon have the time, hopefully soon have the time to do that. And there's a lot of planning going on right now. There's so much going on right now, which is great. But yeah, I will. So just keep an eye out for those things. It'll be flowing in. Communication will get a lot tighter as well, as I get a little more time about that stuff. You'll get it all. You'll definitely get it all. Any resources you recommend for learning Terraform outside of the docs? Outside of the docs in here, so Terraform is interesting. I think Terraform is. I would just play with it. I know that sounds I know it sounds like the answer of like when people are like, "Oh, how do I get better at Python?" And he's like, "Just build stuff." Like, yeah, like this is a little more straightforward. Like that's a little bit harder because it's like what do I build? Why am I building these things? I think because this is very direct. I think that helps you, but it also might be the thing where you're like, oh, well, like, yes, I could practice this, but I have no idea what would matter. I don't have a direct answer for you now. I'll keep an eye out for things that are specific. I've seen a couple of good YouTube tutorials that take you through some interesting architectures. And I think that's where a lot of the learning for Terraform comes into, just like the different ways you can connect services, the different ways you can use this to provide solutions to things, I think is the tough part about knowing how to use it really well. Cause you can you can generate whatever you want, but if you don't know what you first need, like if you first don't know what you need to be building, it's very hard to automate it. So I don't have a good answer, but I will keep an eye out. I think that's very interesting. I'm putting that down here as well as something that I can start looking into, very specific resources for learning Terraform. I like that. Because I think there's a lot of things that'll tell you syntactically how to do things, and like will tell you, you know, how to use certain features and things. But I don't know. I think you can go deeper than that. But that is all I got here. But cool. I'm gonna give you guys your evening back. We got through it pretty fast. Again, Vape Juice Jordan, really appreciate it. Thank you. Thanks for the raid. We're about to find somebody to raid in a second. But yeah, get ready. We have Ansible coming up on Tuesday. We got some object-oriented programming coming in tomorrow on the Python bootcamp all week, really. I'm not streaming this Friday. I'm not doing office hours this Friday, but I will be doing office hours next Friday. So 2 weeks from now, I'll probably keep it on a 2-week cadence. So if anybody wants to play any Overwatch or Rocket League, or maybe Call of Duty, if I can take some time to get good at Call of Duty again, check us out on Fridays. We'll just be relaxing, talking about tech. Come ask your questions. If you got questions about the industry, questions about specific things that we didn't get to answer here, definitely join in and just ask away. It was pretty relaxing for me. I kind of needed it. So we'll just keep doing it probably every other week, because I need the other Friday to do work, again, trying to create a bunch of stuff without a lot of time. So yeah. So again, really appreciate it tonight. Good stream. And I will see y'all later. Who are we rating tonight? I have no idea who's on. Let me check this out. Let's see. Is Prime again on? He's doing Vim Royale. We're heading over to the Prime again. Thank you very much. Let's head over. And I'm probably gonna watch. I really love Vim Royale, so I'm gonna watch it while I'm doing a little bit of work. Every time I need to bookmark this, or like put it to my copy and paste thing, because I spelled this wrong at least 3 times before. All right, I got it right the first time this time. Thank you. Everyone have a great night. I will see you on Tuesday or tomorrow. Your choice. Peace out. Let Prime again know I said hello. What's up, Lucas Florani? Thank you.
I got so excited about the raid mastermind. My camera went out of focus. Holy cow. My goodness, that raid was girthed out of your mind. Hold on. Thank you, Mastermind. How was it? How was the trickle it down? Trickle in, people. We got room tonight. We got room in the startup tonight. I just got done clearing out Opti's Cube.